there, and thanks so much for joining me for the second video and last video in Module 5. So in Module 5, we've been talking about validity, but thus far we've only talked about reliability and validity in the context of your measurement instrument or the test or questionnaire that you're using to assess a construct, right? So in this particular video, I'm going to talk about reliability and validity in a slightly different context. So instead of talking about tests that are reliable and valid, we're now going to shift our focus to talk about reliability and validity of experimental designs. Okay, so when we talk about experiments, there is one primary means of establishing reliability, and that's through the process of replication. So just like I mentioned in Module 1, replication of experiments is going to be arguably one of the most important steps of the scientific method. So what do I mean by reliability of an experiment? Well, the reliability of a study refers to the expectation that we will find similar results when we repeat an experiment. So in research, because we are attempting to find general patterns of behavior, right? We don't want to rely on the findings of one experiment to support our theory, but rather converging results from multiple experiments. So if similar studies or similar experiments find different results, then this suggests that we haven't actually found a pattern of behavior in which we can be confident, right? So replication or repeating a study is one way to test the reliability of a finding from a single study, okay? And when we talk about replication of experiments or repeating a study, there's two different forms. So we can either talk about literal replications or conceptual replications. So with literal replications, what happens is we repeat a study in a way that's identical to the original study, right? So we use the same variables and the same procedure to measure each variable and a similar sample, right? So for example, if I was doing a literal replication of the Milgram obedience study, right? I would have to use the same word pair lists that Milgram used. I would have to find the same shock machine, and my confederates who are pretending to be participants would have to read from the same script, for example, right? And I would operationalize my variables in the same way. So everything would have to be identical to Milgram's original study, right? Which would actually be impossible to do because it would be very unlikely to be approved by my IRB committee. But at least theoretically, that's what I would do, as opposed to a conceptual replication. So most of the time, we don't actually redo a study in exactly the same way, but rather we conduct a conceptual replication by examining the same patterns of behavior or relationships in a slightly different way, or by including additional variables, right? So let's look at a couple of examples here. Okay. So researchers found in an initial study that hands-on experiences for students are more effective at deterring plagiarism than simply explaining the penalties for plagiarism, right? So a hands-on experience that allows students to learn about plagiarism and academic dishonesty is more effective at deterring or preventing future plagiarism than simply sort of talking about it or explaining it or lecturing it about it. Right? And there have been a series of conceptual replications, right? So for example, Schultz in 2004 had students complete a homework assignment about plagiarism, and they showed less plagiarism on their final report in that course. Another team of researchers required students to show 100% mastery on a quiz about plagiarism, and they showed fewer plagiarism mistakes and a better understanding of the consequences of plagiarism. Okay. Another researcher found that students who completed an essay assignment about plagiarism that was assessed for non-originality, which means essentially it was put through a plagiarism detector, like turn it in, and given feedback on that essay, improved in terms of their amount of plagiarism on their final assignment, right? So none of these experiments are identical, right? So they all used different variables and different operational definitions for hands-on experience, but they all found similar results, right? So although each of the studies I mentioned examined a different type of hands-on experience, they all found similar results, or they all came to the same conclusion that plagiarism was better understood and avoided by students after they had a hands-on experience. Um, uh, so even though each of these hands-on experiences were defined differently and executed differently, they were able to replicate the general findings of Schultz's original study. So in other words, the hand-on experience had a reliable effect on reducing plagiarism. Okay, so this is the kind of reliability we seek when we conduct experiments, right? So we expect that the results can be replicated or repeated in future studies, okay? And if the studies examining various types of hands-on experience had not found similar results, then we would question the reliability of Schultz's original study and maybe be skeptical of their results, right? But because we found consistent and reliable results across several studies, okay, that indicates that those results are at least reliable, right? They might not be accurate, but at least we know that they're consistent. Okay. So now that we've talked about how experimental studies can be shown to be reliable, let's talk about validity, right? So when we talked about the validity of a test or questionnaire, there were many different types of validity that we could assess. But when it comes to experimental designs, there's actually only two types of validity that we need to concern ourselves with. So internal validity is the extent to which we are able to say with confidence that no other variable besides the one we are manipulating is causing change in the dependent variable. Right? So how can we increase internal validity? Right? Well, if you think back to my very first video about experimental designs, one of the best way we can ensure that only the variable that we're manipulating is causing change in the dependent variable is to be mindful of things like confounding variables, right? And one of the best ways we can eliminate confounding variables is by using random assignment, right? And not only by using random assignment, but also making sure that the procedures that our participants go through are going to be identical across groups, except for whatever we're actively manipulating in the independent variable, right? And we also want to use things like control groups, right? And we want, again, the experience of those in our control groups to be identical to the experience of participants in the experimental group, except for the critical independent variable, right? So if you guys think back to your first homework assignment where I gave you all of those little descriptions of experiments and correlational studies, and you had to indicate what some of the limitations of the study were. You might remember the study that was looking at the effect of caffeine on memory, right? So they had the experimental group that either drank, or the groups of participants that they had either drank 0 ounces of Jolt Cola, 17 ounces of Jolt Cola, or 36 ounces of Jolt Cola. And one of my potential criticisms of the study is that the control group, or the participants who drank 0 ounces of Jolt Cola, well, they don't have quite the same experience of participants in the experimental group, right? Because they're not drinking anything, right? So again, we want to keep these groups as uniform as possible. So a way to improve the study might be to simply give participants in the control group some kind of non-caffeinated soda, right? So they're drinking something, just like people in the experimental group. The only thing that changes is the amount of caffeine, right? So again, the ways to improve internal validity are to keep the procedure across the experimental and control groups as identical as possible, and to use random assignment so that we can eliminate confounding variables. External validity is the extent to which the results of a study can be generalized to the world at large. Okay. So how can we increase external validity? Well, we can actually do lots of things. So we can make sure that we have as diverse of a sample as possible, right? So, for example, if we were looking at, if we were conducting an experiment on Mercer's campus, we would want to make sure that we have males and females. We would want to make sure that we have people aged from 18 all the way to 22, right? We would want to make sure that we have all different majors represented, right? So we would want to make sure that we have all of the diversity of our student population represented in our sample. And we would also want to make sure that our setting and procedures are as realistic as possible, so that we have a greater likelihood that the results will generalize beyond the particular people in our sample and beyond the particular setting of our experiment. Okay? So how do we make sure that we can generalize our results from a lab setting? Okay. Well, before we discuss ways to potentially do that, we need to familiarize ourselves with a couple more key terms, right? So again, the point of or the way that we generalize from a lab setting, right, is to make sure that our experimental procedures and setting is as realistic as possible. But the question becomes, how do we define realistic? Well, there's a couple of different perspectives on this. Mundane realism is the extent to which an experiment is similar to real-life situations. Okay, so that is mundane realism. But there's also something called psychological realism. And psychological realism is the extent to which an experiment triggers relevant psychological processes, right? So one of the arguments that proponents of experiments done in lab settings is that even though we are in this artificial lab setting, we can still have a realistic experiment, provided that whatever task we use or whatever conditions we select are going to trigger the same psychological processes and group dynamics that happen in the real world, right? So even though our literal setting might be different and much more artificial than the real world, provided our participants are reacting in the same way to our laboratory experiment that they would in the real world, okay, then that means that our results are going to have external validity, or that they're going to be realistic enough to generalize to settings outside of the laboratory. Okay, so again, the key point here in this distinction between mundane and psychological realism is that lab experiments are not automatically artificial because they don't take place in the real world. Okay, what an experiment lacks in mundane realism, it can make up for in psychological realism, provided the conditions created and the tasks completed mimic the psychological processes that participants would encounter in the real world. So let's evaluate together two different experiments that attempt to address the research question, does lighting affect productivity? Okay, so our first experiment that we're evaluating, we give people a production task in the laboratory. So it doesn't matter what type of production task we give them in the laboratory. And then we manipulate whether the laboratory has bright lights or whether the lights have been dimmed, right? And then we measure how quickly and accurately they perform a task, right? So that very directly addresses whether our variable of lighting or having a well-lit or dim environment affects productivity, right? But if we wanted to conduct a similar study in the real world rather than in the laboratory, we could do that also. So for example, we could give employees in a well-lit office or a dim office the same production task, okay? And then we could measure and compare their productivity. So we would have two groups of people here, one group of employees in a well-lit office and one group of employees in a dim office. And then we could compare how quickly and accurately participants in these two settings perform their task. right? So both of these studies very effectively answer the question, does lighting affect productivity? Right? So real life situations are going to offer high external validity, right? Because real life situations are, by definition, the same sort of situations that we encounter in our normal kind of daily lives, right? So there's a lot of external validity there. But it's going to be hard to rule out other explanations. And if it's hard to rule out other explanations, then that's going to indicate low levels of internal validity, right? So, for example, if we find that in our study 2, we find that participants in the well-lit office are more productive, so they can more accurately and more quickly perform whatever their task is. That could be due to our lighting, the presence of a well-lit environment, right? But it could also be due to numerous other factors, right? Maybe morale in that particular office is really high, and all of the employees have formed really good relationships with one another. Maybe the boss is viewed in a very favorable light, and so because of that high morale and good relationships between employees, and also the good relationship between employees and their employer, they're more productive, right? Maybe that particular office offers more incentives for productivity. Maybe there's the opportunity to be paid for overtime, or there are bonuses in that particular office, right? So just looking at these results, right, isn't enough to rule out alternative explanations, right? Okay, so there's high external validity, but very low internal validity. Okay, similarly in lab settings, in our first study, they have high internal validity, right? So if we keep everything the same about the particular task and the procedure the same between the experimental group and the control group, right? Then we know that it's only lighting that is impacting productivity rather than other variables, right? And similarly, if we do random assignment, we know that individual difference variables aren't going to be impacting our results, because people have an equal chance of being put into the experimental and control groups, right? So we have high internal validity. We've been able to rule out confounding variables and have random assignment. But lab studies are often artificial, and depending upon the nature of the task, they can't be generalized to the real world, right? So real life situations have high external validity but low internal validity, and lab settings have high internal validity but low external validity. And again, this assessment of low external validity is dependent on what sort of realism you're looking for, right? So if you're looking for, you're looking at your actual environment and how well that environment or setting mimics the real world, then yes, there's low external validity. But if this productivity task induces the same psychological state in your laboratory that it would induce in a work setting or an office setting, then it can be argued that even laboratory settings succeed at giving psychological realism, or the aspect of realism that you're most interested in as a psychologist, right? And that's that it appropriately mimics the psychological processes and group dynamics that are going on. Okay? All right, so this concludes Module 5. So in this module, we've talked about both reliability and validity. of measurement instruments, and we've also talked about reliability and validity of experiments or experimental designs. All right, so I will see you guys in my next video.